Okay, good morning. Welcome to my presentation here at the France UserCon. I really hoped to be there in person this year. I've done a lot of other UserCons, but the French one is the one I haven't done. So I've done some VMUGs in France, but to actually do the UserCon was a great honor. So I'm glad I'm still able to do it, and I'm glad I'm still able to do it virtually. So without any further ado, let me just share with you my screen, and we'll start talking about what we're gonna go through today. For those of you that don't know me, my name is Joe Baguley. I'm the Vice President and Chief Technology Officer for Europe, Middle East, and Africa here at VMware. And my job is I sit in the office of the CTO. I represent our CTO, Greg Lavender, in the region. And I help connect the field and R&D, should I say, or our customers and our partners and R&D. And I spend most of my days talking strategy, product strategy internally and product strategy externally. And so today I wanted to share with you a little bit about what I'm seeing going on in the world, what we're seeing going on in the world in VMware. I'm also going to talk a little bit about some of the announcements that really stood out for me at VMworld, and a little bit about what we think is coming in the future too. So it should be quite good fun. I believe you can ask Q&A. There is a Q&A question here. I'll see if I can get some time at the end to answer those, or maybe answer some as I go through. And also there's a chat, but try and use the Q&A if you can. So let's start off. At VMware, we really, I really should be sharing my screen. There we go. Hopefully I am. Let me just check the screen sharing is working correctly, because it doesn't seem to come up with the right thing. There we go. Yeah, there we go. Right. So at VMware, we talk about we provide a digital foundation for an unpredictable world. In a nutshell, the VMware strategy is around making sure that we have this platform available that is open and ready for change, and importantly, resilient. And resilient is a word that's used a lot within VMware and has been for a long time, but it's become much more important in 2020 as we learn what resilience in both technology and in organizational structures and culture is all about. So hopefully, if you've known VMware for a while, and many of you at the UserCon will do, you'll have seen this slide before. This is the any slide. This really talks to our strategy around delivering the digital foundation, but our vision, which is now reality. If I showed you this slide maybe 5-6 years ago, even 2 years ago, it would have had VMware Vision at the top. Now we truly believe we're delivering on this because we've got there, and I'll explain some of that as we go through today. But let's look at the middle bit first, and then we'll talk about the any cloud piece at the bottom. But in the any application piece, there's a lot of change going on, as you can definitely see. Oh, someone's come up in the chat. Oh, there we go, super. So there's an awful lot of changes, I'm sure you're aware. And more importantly, application architectures are changing. And we know that. I mean, if you've not noticed that there's some kind of microservices, Docker, Kubernetes thing going on over the last 3 or 4 or 5 years, then you must have been hiding in some kind of box. And historically, we're changing from these monolithic applications to microservices. But what's wrong, really, I think, in most people's perception is that either everyone thinks we're all doing microservices and everyone else is not doing anything else, or that this is all going to happen and switch overnight. So let's talk a little bit about how we got here and a little bit of the architecture changing that got us to what microservices is and why. If you look back, application architectures have always changed and evolved. From the very start, when we had mainframes, we then split the mainframe components up and ran maybe the database on one server and the application on another server, ultimately developing into the 3-tier application architecture that dominated the sort of 90s, I would say, and beyond. This then in the 2000s, thanks to x86 virtualization and VMware, drove into virtualized 3-tier apps. So now we have 3-tier applications that run on virtual machines that are spread out. And the virtualization meant that you could further segment the application. You could further split the applications into smaller pieces. We were also doing the same with other parts of the architecture. Technologies that were available both from Oracle and others have moved towards sharding databases as well and splitting them up into smaller pieces. Now, why has all this splitting up happened? It's been driven by a few things. One was just sheer scale. We couldn't get servers big enough or fast enough to run what we needed to run. Nothing drove this more than the internet. The growth of websites and the internet in this century meant that you just literally couldn't have everything running on one server. I mean, if you can imagine something like the Google search engine running on on one database, on one server, it's unthinkable now, but back then that was the only way you could do things in the 90s. And so splitting things up, splitting up the components, splitting up the architecture moved up. First of all, we started splitting up the hardware using virtualization. Then we started splitting up the databases. And then we looked at how do we split up the app. And this is where the other thing came in, I suppose, really. One of the other benefits of splitting up into smaller pieces is you get some level of resilience or redundancy, as well as scale. You get the ability to lose some of those components and still things run on. Now, initially, when that was done in databases, you would, database replication, and maybe it wasn't so fantastic, and losing a piece of a server was a very exceptional circumstance and something that required typically disaster recovery or some kind of response. As we move forward in applications and people started to use multiple cloud components, there was almost an expectation, which was driven by people like Adrian Cockcroft and others, around the fact that we have to build architectures such that any component can disappear at any time and the application still continues running. And that's really the driver behind all the talk here about pets and cattle, or as I called it back in the day, kittens and chickens. But it was this thinking and mentality around application component reliability. So application architectures have got more complex. They've got larger, they've got more scaled. More importantly, applications have become distributed not just vertically into smaller pieces, but also horizontally into smaller pieces. The components of applications are no longer just in data centers. They're now spread across entire architectures. Some of the components might be running in every store or in every vehicle if you're a car manufacturer. Some of the components might be running in every user's hand on their phone. So now you no longer have to look at an application as you go from left to right across here as one thing in one data center that I can put a box around. That's a huge change, both for operations, security, pretty much everything as to how you run things. But again, I talked about this misconception that these applications are changing overnight. They're not. No one is doing this suddenly. In fact, what you're seeing in the marketplace is what we call the 5 R's of the app journey. Now, the 5 R's of the app journey are the sort of options you've got around application portfolio planning, as we call it. And now VMware is engaged more than ever in exactly this conversation with our customers. Not how do I virtualize servers or how do I virtualize my network, but much more around let's look at the application portfolio map that you've got and understand what the options are for those applications. Now, if you're looking at an existing application, you've really got 5 choices. One of them is to just leave it as it is, to retain it, keep it. And that's valid for a lot of applications. For a lot of applications, it makes no financial sense or the ability, or it doesn't make any sense to take the technical risk to do anything to it. It works, leave it where it is, the cost's fully sunk, and it's fine. And we see a lot of customers already doing that. And that could be an app that's already in the cloud. Then rehost or migrate. And that's just moving clouds to the host, moving apps to the cloud and rehosting them. That's literally taking the VMs and dragging and dropping them into the cloud. And that's a huge part of application modernization for a lot of our customers today, driven into things like VMware Cloud and AWS and others. Or you can start to re-platform. And that's taking the applications you've got now, not necessarily rewriting them completely, but putting them in containers and running them in Kubernetes. That's starting to become quite a trend. We're seeing a large amount of customers look at that, but it's very early days in that space. Also, rewrite apps using cloud native technologies. That's build and refactor. You'll hear a lot of people use the word refactor. That's a big job. Taking an application you've spent 5, 10, 15, 20 years or more investing in coding, to suddenly say, let's rewrite this from scratch on a different platform is an epic task. And lastly, you've got the option to retire, which is let's just kill the app and convert and start to use direct SaaS apps as well. So the point here is that when I repeatedly go to customers and I sit in front of a CIO and they tell me, oh, we're all in on the cloud. We've chosen this cloud or these 2 clouds, and we're going to be 50% of our applications on those clouds in 2 years. Myself and my colleagues in the industry will always look a bit quizzically at that CIO because they obviously haven't quite thought it through, because it's never quite as simple as just moving it to the cloud. It takes thought, it takes planning, but also more importantly, it takes an understanding around operations and an understanding around the platforms you're going to run before you even just think about where these applications are going to end up. And that's really been the driver behind what we're doing at VMware. We want to make sure as our customers go forward in this journey, we want to make sure that they are able to still have choice and still able to do what they want to do. Because if you look back at this slide here, in 5 years' time, you're still going to be running virtualized 3-tier apps. Some of our customers are still running mainframes. You're still going to be running all of these bits here as well as that. So actually what you really need at VMware, or what we need from VMware, is what we've been building, which is what we call one platform to run all the things. And this is understanding that you will have monolithic applications. They're not going away. Those traditional 3-tier monolithic applications, virtualized or not, are going to stay. They will need some form of IaaS. They will need VMs. That's not going away either. But as we look at the increasing velocity, you need to be able to provide openness and choice to those people building and running applications such that they can still stay on a platform that is scalable. Because other applications will also need OpenStack, maybe. You know, OpenStack is a huge thing. For us, we have VMware integrated OpenStack, which I'll talk about in a second. But that's very important because that's mainly the platform behind most of the telcos you see today using that for their telco cloud. So OpenStack is huge if you work in telco. Not so much elsewhere, but it's huge in telco. When we look at hybrid and microservice applications, this is where we started to get into the Docker world and started to get in containers. There you need something that's providing containers and more importantly, a Kubernetes API. As Kubernetes has become the standard API for doing this. And then obviously cloud native applications, where you're going to look at things like platform as a service and maybe even functions as a service. All the cool trendy stuff that you hear about and talked about at all the cool cloud conferences. They tend to run on containers, by the way, underneath anyway. So you still need containers to sit and run that PaaS or that FaaS on top of. If I go and talk to a lot of customers, they see each of these as an individual silo. Each of these is, you know, I'm going to build a new platform to do containers on, and that's going to sit in that part of the data center on those servers. I'm going to build a new platform over there to run platform as a service. We're going to, all these different things running in different separate places. It's not what we envisage for VMware, and it's certainly not what we're doing with our customers. We always saw that actually these were just functions of architectural application architecture that sat on top of the infrastructure. So our job at VMware was, how do we make sure the infrastructure is one single, consistent, stable platform? And that's really where, you know, vSphere, vSAN, and NSX come together. Then we didn't virtualize servers and, you know, we didn't virtualize network just because we hadn't done networks yet and we had to virtualize something. We didn't virtualize storage because we were like, okay, well, we've done networks and we've done compute. We should really virtualize storage. We did it because we continually had a vision. I can tell you from the core of what we were doing here at VMware from the strategy team, that there would be a platform that would run across multiple clouds, and a platform that would allow our customers to do any type of activity on top of it and abstract themselves entirely from the hardware whilst doing so, and would scale across multiple clouds and multiple locations. On top of that, we've also then been building products and technologies that you know today. vSphere, obviously, for IaaS. VMware integrated OpenStack, as I mentioned before, which is very key in telcos. Tanzu Kubernetes Grid and Tanzu Application Service and Serverless with Tanzu. Tanzu is the product family name for everything we do applications. And there's multiple things covered here by the word Tanzu. In the case of Tanzu Kubernetes Grid, that's various options for consuming and building Kubernetes in various locations. But what you're looking at really is one platform that runs across both on-premises and the cloud and allows you to have a consistent Kubernetes experience, including Tanzu Mission Control to go across with those. Tanzu Application Service is a true open source native PaaS. This is actually what you used to hear called Cloud Foundry. And in fact, did start at VMware back in 2010, 2011, and was spun out into Pivotal and has joined us back again when we reacquired Pivotal at the early part of this year. And Tanzu Application Service is huge. It's used in multiple, hundreds of companies worldwide, and some of the largest Fortune 100 companies are using Tanzu Application Service, or Cloud Foundry as it used to be called, to build and manage some phenomenal applications at an incredible scale. And then serverless with Tanzu, we've got stuff and things going on there that I can talk about another time, where we're looking at how we can further support and integrate serverless into the Tanzu story and into that platform. So when you hear Tanzu, just think modern applications at VMware and every option in between. So, much like you'd hear someone say, for example, talk about Anthos or OpenShift for VMware, that's Tanzu. But it's important to talk about this piece underneath as well, because the piece underneath can run anywhere. You can run this vSphere, vSAN, NSX operating system for data centers, as I like to call it, both on premises, on your own private cloud, whether that's Dell or other hardware, and hyper-converged, such as VxRail or similar. And that's what Cloud Foundation is. VMware Cloud Foundation is that operating system for the future. It's that future-ready cloud platform that is run and consumed anywhere. And more importantly, we now have pretty much every public cloud you can think of, in fact, every public cloud you can think of, running that. So the driver behind what we're doing here at VMware, the core to our strategy, is to enable our customers to grow what they've already built, the stuff they've been building for the last 20 years with us on premises, and then extend that both up the stack with Tanzu and across the stack in terms of where physically you run it, so that they have ultimate choice and openness. And the key fundamental here is, as you'll see from this slide, is we're not trying to sell customers our cloud. We're not trying to work out how to get customers to lock in or move all their workloads to our cloud. We're trying to make sure our customers have the choice of any cloud, be that on premises, be that out in the public cloud, or be that at the edge. True hybrid multi-cloud. And we believe at VMware we're the only people able to do that. So let's look at some of the modern app stuff and what's happening in modern apps and how modern app connectivity is actually changing. Because modern apps is driving new thinking in how we build applications, but more importantly, how we secure and manage the networking and the parts of the application itself. If you look at a real world modern application, and this actually is quite an old picture you'll see here from 2014, but this is just a good example that we can use publicly of, say, for example, Halo. What you're looking at here is the application architecture. Every line of text here represents a service, and every line going across the middle of this circle is a communication pathway between two different services. And that just shows you how modular and complex a modern application is. And I can tell you, most that I see are way, way more complex than this. This is actually quite a fairly simple one here, showing you what actually goes on. But this is a good example of why now you need networking and security to be entirely different to how we know it today. Most networking and security thinking is built on three-tier applications. I have an application server over here, I have a database over here, and I need to make sure there's security between that. And then between the application server and the public cloud, there has to be, the internet, there has to be some form of load balancing and some firewalls. And then you suddenly land in the world of microservices, where that just scales to a way that no one can understand and no one can build. If you look at how you do this in microservices, microservice to microservice comms, you start to get what we're talking about as service meshes. And the thesis behind a service mesh is that there's a common set of underlying network tasks, such as routing, retries, load balancing, even authentication, that can be abstracted away from both the applications and the underlying networks. The mesh, therefore, is nothing but a network of software entities that perform these tasks for different services. Without this sort of abstraction of this service mesh, you either have to embed these tasks as part of the networking infrastructure, e.g. sort of down in layer 3 or layer 4, or even down into physical, or code that into the application layer, such as up in a layer 7 network overlay. However, in a microservices environment, which is rapidly changing and scaling and hugely complex, neither of these options is ideal. And that is why you're hearing us talk about things like Tanzu Service Mesh. Tanzu Service Mesh brings you that ability to start to do those higher order things, authentication, security, firewalls, etc., and put those into a mesh that sits within the application. We have some initial production customers now for Tanzu Service Mesh. And what we're looking at there is things like multi-cloud federation, and obviously you also see it does tight integration with NSX. But what you're looking at here is moving up that thinking that we now have with NSX, but putting that up actually between some of the application components. Taking that even further is Antraya. Antraya is an open source project, which we're also working, contributing to, which is about essentially the easy way to understand this, if you already know NSX, is putting NSX and sort of taking those NSX services, those up to cluster level, and giving you cluster level networking and app and connectivity services deep into your application. So rather than NSX just extending up and sitting under the VMs, this is going past the containers and deep into the application architecture, higher and higher up the stack. So all that work that you're doing, embedding and building the NSX at the bottom now, is actually going to pay off dividends when people start to deploy services on top of that and you hook it into Antraya. I mentioned Tanzu earlier. Tanza Editions is something we announced recently, just before VMworld, actually in September. And this is now a different way to consume, and probably a much simpler way to consume and understand what we're doing in this application space. So on the left, you've got essentially, which is Kubernetes adoption, which is Tanzu Basic, which is Kubernetes with vSphere, Tanzu Standard, which supports multiple clouds. And then on the right there, you've got options that also include Tanzu Application Service, so Cloud Foundry. and that's Tanza Advanced and Tanza Enterprise. They're including more and more tool sets on top and further, such as DevOps delivery tool sets and as you say, in Enterprise, full developer velocity and automation tool sets on top. It's a much easier way to understand how you're going to consume different versions and collections of Tanzu Kubernetes and Tanzu application server. Let's move a little bit on now to multi-cloud and talk a little bit about this multi-cloud story. I keep talking about you can consume on lots of different clouds. What's that like for our customers? What's the reality today, and what have we been doing and working to help that for our customers? Well, the reality for most of our customers is that they are multi-cloud. They are using different clouds, usually at least 2 that you'll see here, but many, many more sometimes. But there's challenges across these different architectures, like operational inconsistencies, varying skill sets of people, different management and security roles, et cetera, et cetera, et cetera. And so, people tend to look at these as the new silos of IT. In fact, I did once have a conversation a few years ago, 3 or 4 years ago now, with a CIO who said to me, his problem with using multiple clouds was that he was almost building the same silos that he had in the early 90s with different types of mainframe. So, I think they kind of see the vision here and the understanding that we have behind having a distributed system that allows you to bring together infrastructure, operations, security teams across these, because they all have different operating models. When we talk to global organizations about these challenges they have, there are these challenges they highlight to us, operational inconsistencies, varying skill sets of people, different management security controls, inconsistent app SLAs, and incompatible hardware and technology formats. And to manage these different apps and architectures on an infrastructure, IT organizations are desperately needing to become more agile. And there's going to be a better way to do that. IT's got to be able to treat all of this consistently in order to power those applications. So the way that you have to transform your approach, your IT architecture has to transform towards a hybrid cloud model, not a silo per cloud. And so, when we actually look at how that works, people are looking for, freedom to build for any cloud and secure and efficient operations. They need consistent operations across clouds, consistent developer experience, multi-cloud security, app portability across clouds. And this again was a study that was done earlier this year. So how can you have developer freedom with consistent operations? Well, obviously, that's what we've been working on here at VMware. The driver behind what we're doing is moving towards these solutions away from products. And really, our customers are asking for us to have separate offerings for multi and hybrid. But what we really want to do here is actually bring this all together. So at the top, you're seeing a drive around multi-cloud operations. Those of you who know will know that's deep into what we're doing in vRealize and what we're doing with the vRealize and the cloud management product set up there. Then down at the bottom, VMware Cloud, that's everything I've talked about already. VMware Cloud Foundation and all those pieces can run across both the edge, your data centers, managed data centers, and the cloud. And I'll talk more about the edge later, actually. But also, people are still going to use native public clouds. We're not blind to that. And that's why the multi-cloud operations piece you see at the top goes across all of that. So you've got this option here to run the VMware Cloud anywhere, including in any public cloud, but also you have the option to then do multi-cloud operations across the top of all of the clouds, including native cloud operation models. So this consistent operation model, this multi-cloud operations and infrastructure sits as you'll see here. You have this ability with the cloud platform services running on top of vRealize and Cloud Health to provide management for both VMs, containers, and Kubernetes across both on-premises and public cloud, but more importantly, the VMware Cloud Foundation-based workloads and native public cloud. So what you're seeing we're doing with Tanzu spreads across the existing VMware infrastructure, be that public or private, and also includes and contains native public cloud operations too. So products like vRealize and Cloud Health, they're stretching across everything, not just VMware. And then underneath that, you'll see NSX and VMware Carbon Black stretching across both the VMware Cloud Foundation-based workloads and native public clouds too. So as you go through that journey, you go through those 5 R's I talked about earlier of what are my options with applications. What you're seeing here is this unified operations model that sits across all of that. So as you do whichever one of those 5 R's you want to do, you continue to have unified operations as you do that. And so the VMware multi-cloud strategy really is around the ability for our customers to build, run, manage, connect, and protect any application on any cloud. And you can see now we support not just VMware, but also AWS, Microsoft Azure, Google Cloud, Alibaba, IBM Cloud, Oracle, in fact, 4,500 public cloud providers worldwide. And there's been some news recently at VMworld. There's been updates to Tanzu. There's updates to VMware Cloud. There's updates with VMware Cloud DRS as service, which I'm going to talk about in a couple of slides. We've got updates to the vRealize, new versions of Cloud Health, obviously VMware NSX, Tanzu Service Mesh, and Project Antraya already talked about, and huge advances in what we're doing in integrating Carbon Black to help you as our customers build, run, manage, connect, and protect any application on any cloud. Continue to have that distributed operations model that goes consistent across all of these areas. Just to talk a little bit more about what we've done with the hyperscalers recently, you can get the VMware Cloud, as I said, VMware Cloud Foundation on any of the major hyperscalers. Excuse me, a bit of a sore throat this morning. And as you'll see here, we are available on both Azure, Google, IBM, and Oracle. These are the ones I wanted to highlight here on top of the normal VMware Cloud for AWS that you all know. And here, there's differentiated reasons why people might want to go and run their VMware-based VMs on VMware Cloud Foundation in these areas. For example, in Azure, they might want to start to have integration with the Azure native service or console integration. With Google, you may be looking at some of the G Suite integration. Maybe you wanted to use the AI and ML HPC services that are available there in addition, in conjunction with what you're doing on your VMware-based VMs. IBM offers integration around Watson, regional availability that you don't get with other clouds. And obviously the Oracle one, you're looking here, this unique customer value includes Oracle app migration, database access, and customer managed options as well. The bottom line here is that this is unprecedented customer choice with unique capabilities and all with unified VMware infrastructure across them. The thing I mentioned a little bit earlier about cloud disaster recovery, we actually announced the new on-demand DRAS, or on-demand disaster recovery as a service at VMworld. And this really delivers an easy-to-use SaaS solution with cloud economics. Blue on this, by the way, is your steady state operations, and purple is what gets activated for tests, failovers, and failbacks. But what you're looking at here is a cloud-based orchestrator and a cloud-based scale-out file system that we then run on VMware Cloud on AWS with this on-demand failover target. And that will give you the ability to instantly power on and spin up SDDC clusters in the event of any kind of failover, and also includes Delta-based failback when needed to existing on-premises. It's on demand. There's no VM format conversions and rapid recovery from any kind of incident. It's really easy to use, and you only pay when the capacity is needed. This is a really good example of one of the cases that's outside those 5 Rs, where also people are looking at how to use the cloud and how they're embracing the cloud a lot and what they're doing. Something else I wanted to highlight today, and I think probably is got most of the news at VMworld, is something that I've been very excited about for a while now. And we worked on the first demo of this, those of you who maybe spotted it, at VMworld 2019 in the CTO keynote with Greg, where we demonstrated SmartNICs. There's this profound evolution of what's going on in hybrid cloud architecture, spanning the data center, edge, and telco cloud. There's a lot of things driving how we build the fundamental architecture underneath what's going on here, the physical architecture, the servers, and how they're going to change. Now, VMware's already driven one major change of data center hardware. The first change we drove was hyperconverged. Some of you may remember Project Marvin, or what became ultimately VxRail, was that driver around having servers that have onboard storage and a lot of compute and RAM and a network card. And that then drove the architecture that now we know as hyperconverged through the data center. Well, this is the next big wave of change in the data center after hyperconverged. If we look at what's actually happening, I've talked a little about some of these next-gen applications, the massive scale that they run. They put different loads on servers. They put different loads on architectures. And if you look at cloud native and specifically telco 5G transformation as well, it comes up with a dramatic increase in network traffic and creates performance and scale challenges. Just think back to that architecture I drew for you earlier for that modern application. There's also machine learning and data-centric apps, and those are actually giving you some kind of hardware acceleration requirements. And obviously the multi-cloud and hybrid app, as hopefully you've worked out by now, if I'm splitting my bits and pieces up across multiple data centers into smaller chunks, then security is going to be very, very different, and I need a different security model. So let's look at a couple of these as we go through, specifically the NICs and the composable servers piece, because this is what drives us around next generation infrastructure. But also you need hardware multi-tenancy as well. This is where Project Monterey comes in. Project Monterey you may have heard referred to if you're looking at some of the news in around VMware. But what Project Monterey does is it uses SmartNICs to really maximize performance, give you zero trust security, and simplify operations. And it essentially extends VMware Cloud Foundation as a unified platform for all applications, including bare metal. And that consistent digital foundation I talked about, that reliable, flexible digital foundation, that's really where this comes into its own. So let's talk about what SmartNICs are and how they come together. Excuse me. So a SmartNIC is a network card with a CPU on it. It's the easiest way I found to explain this. So your standard network card, but instead now it also has a CPU on it, and in most cases, some form of programmable accelerator, either FPGA or some cases a GPU, and a high-speed interconnect between those. These things are now being made by people like Mellanox, which is now part of NVIDIA. You're looking at Pensando, Intel, and others, all looking at making these SmartNICs. And typically, the application, the CPU on these SmartNICs is an ARM processor as well, which is another story. So when you now realize that people are dropping these into data centers, we have to think about, well, what can you do with these? What's the potential? And that's really where we looked at this, because originally people are saying, okay, fine, I can start to virtualize network device functions. So I can say, okay, I can do certain networking functions I can run on this card. But we looked at and thought about this, and also talked to NVIDIA and others, and thought about where could this really, really go if we pushed it. So if you think about the standard architecture today, this is the architecture you build and know and love, is that you have your ESXi and in VMware Cloud Foundation, obviously NSX is running in part of ESX as part of the kernel. You've got vSAN storage running in ESXi. You've got the host management, as well as the compute hypervisor parts. All of those functions running there, and obviously a network card for them then to talk to the network. If you introduce a SmartNIC, the first thing you get is a security air gap. You've now got a processor that's executing or has the ability to execute things completely and utterly physically separate from the host CPUs. That's quite a big step, and actually gives you some real functionality in terms of security. And that's where a lot of people thought this was going to go initially. But here's where I think it's going to go, and here's where we're working with Project Monterey live in some projects with some customers today. If you look here, what if we got the host management piece, the storage piece, and the networking piece, and we move those to run on the NIC? So now on the network card, NSX, the networking security services, they're all running on the network card. vSAN controls, all the bits to do with vSAN, all the storage controls, all running on the NIC. And obviously host management also running down there as well. So we can now let the compute hypervisor do compute things. And down here, I have everything running on the network cards. That's the fundamental change. Some of you may, who are deep into this, may be aware of things like AWS Nitro, for example, and other technologies, which some of these hyperscalers are using to do very similar in their data centers. It's pretty much the same. And what you're seeing here is us bringing that to the mass market, the ability for you to have offload of network security, storage, host management, etc., to dedicated hardware. This has also been enabled because if you remember earlier on, I said that those network cards have ARM processors on. We now have ESXi for ARM. It's available as a fling on our website. So if you wanted to run ESXi on a Raspberry Pi 4, you now can. And in fact, there's a load of people doing that. But obviously, you can also use ESXi ARM to do things clever with SmartNICs. And that's what we demonstrated last year and again this year. I mentioned bare metal. It does give you the ability to run things on bare metal. If you have a look here, this security air gap, but also more importantly, because NSX and vSAN and the other pieces are all running down there on the network card, I can run a bare metal workload directly on the server, Linux or Windows, for whatever reason you might want to do that. Of course, everything should be virtualized, but there's odd cases where you wouldn't. They now can have access natively to all of those VMware Cloud Foundation services that we talked about earlier. So if you want to look at what the shift is going to be in your data centers over the next few years, and this is really a project for us starting now, but we're looking at it realistically over the next 2 years or so, is Project Monterey will mean that now you're going to have a fundamental architectural change where you'll be managing multiple hypervisors on one physical server. One hypervisor is going to be the hypervisor you already knew, ESXi, sat there doing the compute. The other is going to be on one or many smart NICs that are into servers that you're plugging them into. So you could theoretically have 4 or 5 hypervisors running on one particular server, depending on how many smart NICs you plug into it. It's a big change. But I think, and we think at VMware, it's a really interesting direction that the industry is going in. So lastly, I wanted to talk for a few minutes about security and what we're doing there. There's no doubt we've heard for many years that security has to change. Security has to change from being bolted on to being built in. You have to understand that when you look at what we've talked about, everything I've talked about so far in the last 35 minutes, all of it is about applications getting more complex, application components being more distributed, things being both inside and outside the data center. You can't just wrap firewalls around that. You need to go towards what we call intrinsic security. You need to start putting what you used to wrap around things actually inside the application. Also, we can no longer be reactive. We need to start to be proactive in what we do here. We need to start predicting what's going to happen. We need to architect for security as opposed to put things in afterwards. And also, how we think about all of this has to be aligned with the team that's building it, not just siloed and stuck out in a separate area of people called the security team. We've already been through this at VMware. When I first started, we were trying to get the network and storage people to talk to the compute people so they could come together and build a cloud platform. Well, now we want to put our arms around the security people too, and let them be part of this story and make sure that those work in harmony with the network security, network and storage and compute that are now the cloud platform team. Those guys should be doing security just as much as everyone else. Intrinsic security is in our DNA. We're incredibly well positioned for it. From the first time 2 VMs shared a host, there's been security in their isolated compute. vCenter with role-based access control, encrypted comms, encryption of data at rest at vSAN, and all the work we're doing with Workspace RON around identity with Workspace ONE and endpoint security, VDI, mobile devices, laptops, and obviously, goes without saying, NSX, the change that we brought to the data center with micro-segmentation and firewalling within the network overlay. The other thing to understand when you look at what we're doing with VMware is we start at an architectural point where others aspire to be. This was referred to many years ago as the Goldilocks Zone by Martin Casado. But what you're looking at here is for each entity, we know the full context. We don't have to install an agent to see all that goes on with a virtual machine. We don't have to do something just to see the network, because everything that VM looks at, or that container also now under Project Pacific or vSphere 7, every workload that's running on ESXi, we are its whole world. We provide everything. So we can see not only the network stuff and maybe the things it writes to disk, which other people can, but we can also see every single thing it talks to on the CPU. We can see everything it writes to cache. We can see everything it writes to memory. We can see all the protocol handling it does. In fact, we are incredibly well positioned, more than anyone else, to understand and build security into applications going forwards. Add security onto that, and really, that's where we become the most pervasive software in the hybrid cloud, because we are. Whether it's on-premises running in VMs, whether you're doing that for Kubernetes bare metals, whether you're on AWS Outposts, Azure, we have the ability to inject intrinsic security natively into what we're doing. A really good example of how that's so comprehensive is if you look at networking now. No one is better positioned for networking security than VMware. We have the ability with NSX Data Center and Cloud Platform to provide you with advanced analytics around everything that you're doing in layer 2 to 7, switching, routing, software-defined firewalls, application delivery controllers, load balancers, service meshes, and then in SD-WAN with what we're doing with VeloCloud, we've got the ability to support you with cloud connectivity, routing, security access, etc. So you're going to see a big change from us going forwards. We've already started to talk a lot about security, and obviously there was the acquisition of Carbon Black earlier this year that made a huge impact into that story. But more broadly in what we're doing at VMware, you're going to see a story from us around this intrinsic security paradigm. We're going to work with you, our customers, as to how we bake security into infrastructure, how we distribute security to the data and the applications, and help you get a deep understanding of the application topology and behavior. We want to focus on reducing the attack surface, and also mean that less people have to think about security because the platform is just secure by design. And that's really, really, really important to us. There's many devices we have in our hands today, mobile phones, for example, that are secure by design because the users can't be trusted or expected to have the knowledge or ability to maintain and manage the security of that device. We have to build it in. We have to do that to applications. We have to do that to infrastructure too. And so that's a huge focus for us going forward at VMware. The last thing to talk about here that I wanted to touch on is some of the stuff we're doing around Workspace 2.0, specifically Secure Access Services Edge. Some of you may have heard talk of SASE recently, and this has been highlighted more than ever in the recent pandemic as people have been sat at home working alongside the rest of the family, and the rest of the family are doing other things, whether they're attending virtual university or virtual school, trying to do their job, or just watching Netflix or playing on the Xbox. What VeloCloud by SD-WAN allowed our customers to do was to extend their corporate WAN into their home in a very, very easy way by just deploying a physical box and plugging it in that was then centrally managed and scalable. But it also allowed things like traffic prioritization and allowed you to optimize traffic for workloads and important applications over and above Netflixing and Xboxing. And just by deploying that alone, that's reduced network performance issues by up to 90%. And that's based on a single enterprise deployment of about 5,000 home-based SD-WAN users over a 1-month period. We did this SD-WAN monitoring data. And this has been a big change for a large number of our customers in recent times as they start to realize that SD-WAN isn't just about branches, it's about the home too. But what we're finding is that when you looked at how that architecture was built out, a lot of the security services that people were running, authentication and other bits and pieces, were all running in the DMZ back in their data centers. So we were extending an SD-WAN out to the end user, but they were still having to go back out all the way over the internet, all the way back to some data center on the other side of the world, some corporate data center, to get access to those services that were running in the DMZ in that data center. Someone down in South America, for example, was having to connect to Europe just to get their services. That was causing problems. Secure Access Service Edge actually allows you to take all those functions and distribute them out in the network to all the points of presence, both VMware points of presence and customer points of presence and others with our service providers. That then allows you to start to say, okay, fine, if I'm in South America and I want to talk to an Office 365 server, I don't have to go via my corporate DMZ in North America. I can talk directly via a POP to the Office 365 there, but get my corporate security monitoring. And that's really where Secure Access Service Edge comes in, because not only does SD-WAN by VeloCloud make it easy for you to extend the SD-WAN, but SASE allows we can push things out like the Zero Trust Access components, the NSX firewall, and web security functions and have them distributed in every POP. Really, that's about securing and optimizing app access. And it delivers zero trust through this sort of continuous risk evaluation, real-time enforcement, and consistent policies across users. And it gives you that freedom to work anywhere with exceptional end user experience across any device through the whole employee lifecycle. So, what we're doing with things like Secure Access Service Edge is enabling this secure distributed workforce story, truly enabling our customers to consume any device, any location, and any cloud. So all that stuff I talked about, all those applications you're building, all those modern applications, we can now deliver and secure those anywhere and enable our customers to securely consume those applications on any device, in any location, delivered from any cloud. So yes, your users want to use a SaaS service, integrate that with what you're doing and consume it locally. We can do that using SASE and all the work we do with Workspace ONE. So bottom line, our trusted digital foundation that I started about, all the cool stuff that we're doing around Project Monterey, the stuff we're doing around MultiCloud, the stuff we're doing around SASE, the stuff we're doing around ESXi on ARM, and all these other different bits and pieces, they're all focused at the core of our strategy is you, your business, your applications, your data. We want to sit with you and take your applications through the journey. We want to make sure that we can help you through those 5 R's, that portfolio planning, understand what the journey is for every single application you have over the next 5 to 10 years and how we're going to help you do that. First of all, we can help you with that through app modernization with Tanza. Secondly, our modern cloud application, our multi-cloud application portfolio with VMware Cloud. Together, app modernization and multi-cloud form our core platform, or our core stack, if you want to call it. I don't like the word stack, but our core stack. They literally go together like two best friends, I think is the best way to describe that. Then there's digital workspace. I just touched on that right now for like 3 minutes, but the digital workspace is a huge thing. It's the key to driving employee engagement. It's the key to making sure that your users can access any application they want anywhere securely. The virtual cloud network extends across all of that, securing everything, both in your data center, in the cloud, at the edge, all the way out to the users. And more importantly, you have this intrinsic security. Put that all together, and you have the digital foundation for an unpredictable world. Thank you very much for listening this morning.